Hello, this is Mrs. Neill, and this is lesson number 17, the Pythagorean Theorem. Okay, our concepts that we're going to go over today are the Pythagorean Theorem, and we'll do several examples on the theorem today to get you familiar with that. We're also going to talk about the converse of the Pythagorean Theorem, and we're going to talk about when you do your values of a squared equals b, c squared is equal to a squared plus b squared, it's going to be a right angle, or it could be an acute angle if it's less than, or it could be an obtuse angle if it's greater than. So, in your Algebra 1 class, I bet you already have gone over the Pythagorean Theorem, so this should not be totally new to you. But first of all, let's look at a right triangle to get started. We want to label the sides A, B, and C. Now, in a triangle, universally, when you label it, the angles are capital letters, and the sides are written with lowercase letters. And angle A is going to be opposite side A. Universally, this is the way you label a triangle. Angle B, side B is going to be opposite. And then angle C, you notice, is our right angle. It's going to be opposite, and that's side C. So let's now label the hypotenuse. The hypotenuse is always opposite the right angle, and I'm going to label that with the hypotenuse at C. And then let's label the legs. The legs are the other two sides. So this is a leg, and this is a leg. Okay, so please remember, the hypotenuse is always across from the right angle. That helps you identify it, because your triangle may actually be turned around. It may not be just straight up front. So you can always locate it by looking opposite the right angle to find what the hypotenuse is. And the hypotenuse is the longest side of the right triangle. So if I give you three sides of a right triangle, the largest numerical value will always be your hypotenuse. And then the other two numerical values are going to be your legs right there. So now let's go on and look at the Pythagorean Theorem. Here it is right here. The Pythagorean Theorem is a squared plus b squared equals c squared, which means a leg squared plus a leg squared equals the hypotenuse squared. Now, can I write the Pythagorean Theorem? B squared plus a squared equals c squared. Can I write it that way? Yes, I can, because this is addition. Addition can be commuted. I can add the b squared plus a squared, or if I want to, I can flip it and do the a squared plus b squared. Okay, it doesn't matter what order you add those up in. Okay, so now let's look at a couple of examples. Okay, we want to state the Pythagorean Theorem based on the given triangles. So locate your hypotenuse. In this case, it's Z right here. And this is a leg, and that's a leg. So I'm going to use my Pythagorean Theorem, and I'm going to say x squared plus y squared equals z squared. And that's all we're doing on that example. If I wanted to, I could say y squared plus x squared equals z squared. Okay? You can flip those two legs. Okay, right here, where's my hypotenuse? It's opposite the right angle. So that's a hypotenuse, and that's a leg, and that's a leg. So I can write n squared plus p squared equals m squared. Okay, so that's basically working some problems where we're just setting them up. Now, let's do some values, some problems that have a numerical value to it. Alrighty, let's look at these three right here. If you need to stop the video to write down the problem, you sure can. I'm going to cover up. I worked them ahead of time, so I'm going to cover those up as I go along. All right, here we go. Let's find the value of x right here. Identify what is x. Is x a leg or a hypotenuse? It's It's a hypotenuse. So these are legs here. So I'm going to go leg squared plus leg squared equals hypotenuse squared. And I'm going to set it up as 5 squared plus 12 squared equals x squared. 5 squared is 25. 12 squared is 144. And I add 25 and 144 and I get 169. This is just working algebra now. And 169 equals x squared. Now remember, to get x all by itself, you're going to have to take the square root of both sides. And 169, the square root of that, happens to be 13. So my value for x here is 13. Now let's go back and look at this right here. Remember, the hypotenuse is always the longest side in a right triangle. The longest. So, use your common sense. My answer has to be bigger than 12 since I'm looking for the hypotenuse. I got 13. 13 is bigger than 12, and that's a good answer. If I'd gotten a number, let's say 8 for my answer, that's not correct because I know that this number here has to be the longest side since it's a hypotenuse. Okay, let's look at another one. Here we go right here. We've got a leg, and here's the hypotenuse. So we're solving for a leg right here. So let's set this up. I said x squared plus 3 squared equals 5 squared. So we're solving right here for this value. Okay, let's square those. And I get x squared plus 9 equals 25. I want to subtract 9 from both sides and get x squared all by itself. So I got x squared equals 16. Now you got to take the square root of both sides. You don't want x squared as an answer, you want x as an answer. So right here I'm taking the square root of both sides and I get x is 4. So my answer here is 4. If you notice, 5's a hypotenuse. So 5's got to be the biggest of the two numbers here. So if I'd gotten 8 right here for this length of this side or leg, that's not correct. It's got to be smaller than 5. So use your common sense when you're building these problems. All right, let's do the last one on this little set of examples here. Okay, here's my problem. This is a 1, not a 7. It's 1, and this happens to be a radical. It's square root of 3, and that's x. So what am I trying to find? I'm trying to find the hypotenuse, and this is a leg, and that's a leg. So I'm going to set it up. 1 squared plus square root of 3 squared equals x squared. Okay, 1 squared is not equal to 2. I see that all the time. 1 squared is equal to 1 times 1, and that's 1. So 1 squared is 1. Now, what is the square root of 3 squared? Squared means I'm going to write it down 2 times. So I write square root of 3 times square root of 3. It's twice written down. And that gets me to square root of 9. So what's the square root of 9 now? Square root of 9 is equal to plain old 3. It comes out of the house as a 3. So right here I've got 1 plus 3 equals x squared. Add those up and I get 4 equals x squared. Take the square root of both sides. And I'm going to end up with 2 as my final answer for that. Okay? So this is 2. Now the square root of 3 is not 3. If I found the decimal equivalent, the square root of 3 is around, I believe, 1.7. And that's less than 2. A lot of students look at that and they go, oh, 3 is bigger than 2. That's not a 3. That's a square root of 3. So if you found the decimal equivalent of square root of 3, it would be less than the numerical value of 2. I just wanted to reinstate that. Okay, that's the Pythagorean theorem. Let's keep going. Let's look at the converse of the Pythagorean theorem. Right? So the converse of the Pythagorean theorem is saying if the square of the longest side of a triangle is equal to the sum of the square of the other two sides, then it is a right triangle. Remember, the hypotenuse is always the longest side of a right triangle. I can't say that enough. So instead of a squared plus b squared equals c squared, we're just in the converse. We're going if c squared equals a squared plus b squared, then we know that that is a right triangle there. Now, how do we know? There's all kinds of triangles. We have right triangles, we have acute triangles, and those are all less than 90 degrees. And then we have obtuse triangles. And remember, an obtuse angle is between 90 and 180. So a right is equal to 90, an acute is less than 90, and an obtuse is between 90 and 180. So how do I know if I give you three sides, do I know is it a right angle, an acute angle, or an obtuse angle? Okay, so here, in this case, C is going to be our longest side. It's going to be the longest side. It's going to have the highest numerical value. So if a squared equals, c squared equals a squared plus b squared, then we know it's a right triangle. If c squared is less than, that's a less than symbol, a squared plus b squared, then we know that we're dealing with an acute triangle, not a right triangle. All the angles are less than 90 degrees. And if the c squared value is greater than a squared plus b squared, we know we're dealing with an obtuse triangle. And here's a diagram. Obtuse triangle is between 90 and 180. Okay, so we're going to finish out today's lesson with 3 examples. Let me get these ready. I've done them in advance, so I'm going to cover up my answer here. All right. A triangle has the sides of the given length. Is it acute, right, or obtuse? Okay, if you remember back on our diagram that we did earlier, we said C is the longest side. So whatever is my largest numerical value, you see here I put a C there, I put a C here, and I put a C there, because that's the largest numerical value. That's going to represent the longest side. Okay, so what I want to do is take the first one, example number 6, and I have 8, 15, and 17. So I want to set it up. Here's our formula. C squared, and if you notice I put a blank here because I don't know if I'm going to put equal to, greater than, or less than there. So C is my 17, and then 8 and 15 are just the other 2 sides. Okay, and I'm doing some math now. 289, 8 squared 64, 15 squared is 225. Add your 64 and 225, and I get 289. So I know 289 is equal to 289. So base, see right here, this is going to be a right triangle. They're equal to each other. So my answer is right. It's going to be a right triangle. Okay, let's go on to the next one. And here's my sides are 8, 6, and 14. C is the longest side, so I have 14 is my longest side. So I want to set it up as C squared. See, I have a blank because I don't know if I'm going to have equal to, greater than, or less than in that blank there. Okay, put in my numbers, 14 squared, 6 squared, and 8 squared. Okay, 14 squared is 196. 6 squared is 36, and 8 squared is 64. Okay, add 64 and 36 together, and you get 100. So C squared is greater than 100. Okay, so which one is that one going to be? It's not equal to, it's not less than, it's greater than. So this would make up an obtuse angle. So if I actually drew a picture of this, it would not be a right angle, it would not be an acute angle, it would be an obtuse angle. So one of the angles of that triangle is going to be really big. Okay, one more. This is our very last example today. I have this triangle here, and here's the sides. I have a 7, 8, and a 9. Okay, my C value is going to be the longest side. So I'm going to set up the converse of the Pythagorean theorem. Remember, this is blank because I don't know what I'm going to put in there yet. Sub in your values. I have 9 here, and 7, and 8. Go through your arithmetic. 9 squared is 81, 7 squared is 49. 8 squared 64, add your 49 and 64 together, and I get 81 is less than 113. Okay, so what's that going to be? Is it right, acute, or obtuse? It's less than, so it's going to be an acute angle. And if I drew this angle, a diagram of it, all the angles would be smaller than 90 degrees. All right, that is our lesson for today on the Pythagorean theorem. I'm Mrs. Neill. Thank you for listening.